Hello, I welcome you all. Now in this class, first we'll start with the free body diagram. So free body diagram is what? It's just a graphical way to show the different forces on a given system, right? So let's say that very fundamental or basic example we will see first, that you have one plane is there, right? This is horizontal plane, and on the horizontal plane one block is kept. Okay, so this block is having weight which will act in the downward direction, which you know. To balance this weight, there is a reaction will act, which is act in the direct vertically upward. So reaction you can show by N. Okay, so now that then if I draw this the free body diagram of this system, so the free body diagram for this is what? That is, this is the weight and this is the normal reaction. Okay, so now one more example we can see, that suppose you have one vertical wall is there, okay, and one sphere is there, that one cylinder is there, right, which is hanging with the help of one rope. Okay, so this is the rope and this is the vertical wall. Okay, now so this cylinder is having some weight, let's say the weight is W. So you know that whenever anything is suspended by means of the rope wire, then there is a tension will takes place. That is, means because of this weight there is extension will takes place in this wire, right? So because of that stretching, the tension will develop. That tension we call it as a T, which is in opposite direction to the applied weight. So now the cylinder is acting a force on the vertical wall, so wall will act the reaction on the cylinder, so in this direction, right? So if I draw the free body diagram for this system, so this is the point of action, so this is the weight W, and this weight, because of this weight the tension will takes place in the wire, which is T, and the reaction by the wall on the cylinder, so this reaction you can say that is R or N, anything you can use right now. So this is what the free body diagram. So it's very simple. Now we'll move to the next topic, that is the Lami's theorem. Okay, so Lami's theorem is what? The Lami's theorem is nothing but let's say you have three forces. Okay, first of all you try to understand the Lami's theorem is applicable only when we have three forces is there, and these three forces, how the three forces will be the coplanar and concurrent. So if you have three coplanar and concurrent forces and these forces are in equilibrium, right, then each force is proportional to the sign of the other two forces. So let's say this, you have three forces, the one force is P, okay, and the another force is Q, and the another force is R. The angle between Q and R is alpha, that P and R is beta, and the P and Q is gamma. So according to this, and these three forces are coplanar. Coplanar means what? These three forces are acting on the same plane, and the concurrent means the point of action is common for all three forces, right? So this, according to the Lami's theorem, P by sine alpha is equal to Q by sine beta is equal to R by sine gamma. So this is what you have a Lami's theorem. Now we'll solve one simple problem that which will cover our free body diagram also. So we have a 600 Newton cylinder. It's supported by the frame BCD. The frame is hinged at D. So this is your D. Okay, so the frame is hinged at D, right? And determine the reaction at A, B, C and D. So you have this BCD is a frame. Okay, you can see how I'm showing with the pencil. So this is the frame, right, and this is your cylinder. Okay, now so this the contact the contact point is what? Between cylinder and the frame is B, C and D. B, C and A, and D is this. So you have to find out the reaction at B, C and D and A also, right? So first of all, if I try to know that how these forces are acting. Okay, so actually I forgot to mention the what is called weight of the cylinder. So weight of the cylinder is nothing but which is 600 Newton, it is given, right? So first of all we have to draw the free body diagram, that is FBD of this system. That individual we will draw the free body diagram for the cylinder and for the frame. First of all we'll draw the FBD for the cylinder. So let's see that this is your solution here. Sorry. So this is your solution. Okay, so let's say the weight is given, that is 600 Newton. Okay, now first you can say FBD for cylinder. So FBD for cylinder. So FBD for cylinder is means what? Let's say this is the cylinder, right? And this is the contact point C, this is the contact point B, and this is the contact point A. Okay, so how this reaction? The reaction RA will be like this. Okay, na? Why? Because this this end of the cylinder is contact with this side, so the force is applied by the cylinder on the wall is in this right direction, so the reaction will act in the opposite direction. Same in this sense, the force is applied by the cylinder on the frame, that this side of frame is towards left, so the reaction will act at C towards the right. So this is the RC. Then the weight of the cylinder will always, weight is always acting the downward direction. Let's say I'm writing the W is nothing but the 600 Newton. So the reaction will act where? That reaction will act in the upward direction. This is your RB. Okay, so please draw this. This is the free body diagram for the cylinder. Now we'll go with the free body diagram for the what is called free body diagram for frame. Okay, so frame, how it's look like? The frame is like this, right? So your frame is like this. The frame is like this, right? So let's say this is the center of the cylinder, and then the weight is acting in this direction, that is, you can see weight. So that weight is that this line of action of the point D is inclined with certain angle, right? Now, so this inclination we need to find out. So if I draw like this, right, so you can see there is a triangle is formed. Let's say this angle is alpha. So how this reaction will act like this, that is the RD. Okay, and your RC, you can see here that RC will act towards this side, right, and the RB will act towards the downward direction, right? Now why? Because see here the reaction, this is the weight, right? So this you can say this is the RC, right? This will be the RC for this case. And why? Because that, you know, the action and reaction, right? So if the RD you are taking like this, so in this way that reaction will act this way, and the reaction on B will be in the downward direction. But in for cylinder the reaction was in the upward direction, so don't be confused. Now first of all you can see that from here to here it is 600 mm and this is 300 mm. Radius of the cylinder is which is called as 150. So if I see, this is also your radius, from here to here it is also radius. So it means that just this is your triangle which you formed right now. This is your triangle you got. So it means that from A to D is what? 600 minus 150, which is the 450, right? So you can write this dimension as a 450 mm, and this radius is what? This radius is 150. It is given in the question. So if I see this one triangle is there, okay, now so in this triangle this is the opposite and this is the adjacent. So we can write that tan alpha is equal to opposite by adjacent is 450 by 100 of 50. So alpha is equal to tan inverse of 3. So some value will come. We can get this value, that tan inverse of 3 is equal to 71.56, right, degree. So this alpha you got. Now after finding the alpha, we can see the first we can write for a sphere. Okay, for a sphere, okay, for a sphere summation V and summation H we will write. Summation V is equal to 0. Summation V means what? What are the vertical forces for this sphere? So vertical forces for the sphere is you can see here, that is what RB is acting in the upward and weight, right? So you can say RB is acting upward minus 600 is equal to 0. So RB is equal to what? Sorry. So RB is equal to 600 Newton, right? Similarly, here only you can write for a sphere itself, that is summation h is equal to 0. So summation h in the sense is what? That h in the sense is you have a this is the RC is right and RA is left. So you can see, yes, summation h is equal to RC. Okay, RC is where? RC is acting towards the right side. So RC minus RA is equal to 0, right? So you can say RC is equal to RA. Just leave it like this. Now we'll come back to the we will come back to the frame right now. So for frame is what? That for frame you can see here that this reaction RC and this is the RB actually, right? That is RB is nothing but the weight only, and this RD. So RD means what? It's vertical component. Vertical component will be like this, and the horizontal component, right? So horizontal component for this is what? RD cos alpha, and this vertical component is RD sin alpha, right? Hope you are understanding. So now we can say summation V is equal to 0. What are the vertical forces? RD and RB right now. So you can say that is RD is acting upward, RD sin alpha is equal to RB, that is RB is minus, so minus means 0, right? So RD is equal to what? RD is means 0 means RD sin alpha minus RB is equal to 0, right? So RD sin alpha is equal to RB means RD is equal to, you can say RB by sin alpha, RB by sin alpha. So here RB is what? 600 by sin 71 degrees, right? Then RD value you will get right now. So RD value you can get, suppose this is 632.456. Actually we already calculated this value, so it's time taken right now, so that's why we are doing this. So now we can write summation h is equal to 0. So h means what? Let's see that frame. So h means you have this horizontal component of the RD and a RC, but RC is equal to what? RA. Okay, RC is equal to RA. And one more thing, that here you can say this. So first you can say the RC, sorry, yes, RC is equal to RD cos alpha right now. So RD you already got. So RC is equal to what? 632.456 cos 71.56. So RC you got. Okay, so RC value, some value will be there. Let's say this value is not calculated. So 632.456 cos 71.56. So this we got the 200.05 Newton. But you know that RC is equal to what? RC is equal to RA. So now finally your answer will be that RC is equal to RA is equal to 200.05 Newton, right? And RB we already calculated at the beginning itself. RB is equal to 600 Newton and RD is equal to 632.456 Newton. Okay, so this is what your answer. Thank you.